Alright, so this is the moment you've been waiting for. We're going to find the derivative easier, which is known as the shortcuts. So what we do is, the first one we'll take a look at is the power rule. What that means is, what you do is, if a function is given to you, we move with f of x equal to x to the n power. What you would do to the power is that, as you can see, you move the power, turn that into the coefficients, and then the power minus 1. That will give you the slope of the function, or the derivative of function. So let's look at example 1. Take the derivative. So what you do with the power is that turn that into the coefficient, and then the power, take away 1. So in this case, would be 3x squared. So this is the slope of f of x equals x to the third power. Okay, so that's nice and easy. There will be times that we run into a radical function, and remember how much work that we have to do to find the derivative of a radical function, right? So with the shortcut, what I would do is that I'm going to rewrite this, turn the radical into exponent with fraction. So this is equivalent to x to the 1 over 3. So if I'm going to take the derivative, g primes, that's our new notation. So what we do is we move the exponent to the front, turn into the coefficient, and we take the power minus 1. So in this case, it would be 1/3 equal to 1/3 minus 1, which that would give you, sorry, I wrote the x wrong. So that would be negative 2 over 3. Now, we cannot leave this function like this because we cannot have negative power. So we're going to rewrite this. What I would do is that in 3, if you keep in mind, 3 is in the denominator. So I'm going to keep that in the denominator. The x to the 2 to the third is negative, so I rewrite that. I flip that, sorry, it's 2 over 3. 2 over 3. So by turn that into the denominator, we flipped the exponents. Now it turned into positive, and this would be the slope of the function, or the derivative. Okay. Alright, let's look at the next example. What if the function, if we have the one on the what if we have the power at the denominator? With this is the example. So to make it easy for us, I have to rewrite this. Again, we have to review the exponent rule. So if I, instead of on the denominator, which I don't know the rule to do this, so I'm going to rewrite this as numerator by move that to the top. But when you flipped, you need to turn your exponents into negative. So now, the derivative of this function will be, alright, I'm taking the negative 2 in front, right? And then negative 2 minus 1. So that would give you negative 2x to the negative 3. Again, we cannot have negative exponent, so we move it down to the denominator. So this would be the slope of y equal 1 over x squared. So this is the shortcut, the power rule that we can use to find the derivative of most of the function. Most simple function, we can do this. We don't have to use the definition of limit. So this is nice and easy. So that's the basic one. The next one, if we go back, the next one we will look at is the constant rule. The constant rule, that is mean if a function is a number. So let's say f of x is 2. If some of you recall this from your homework on last week, right? We found that the derivative, and the derivative of this function is 0. We know that because if I graph this one, it's a horizontal line, which means the slope is 0. So to explain this problem, the one way that I would look at this is 2 is the same as 2 times x to the 0 power, right? Because anything to the 0 power is 1. So if I'm going to take the derivative of this one, that would mean I'm going to take the exponent, in this case is 0, times the coefficient in 2, which turn into 0. And on the top, 0 minus 1. It doesn't matter what x power is, so 0 to the negative 1, but if you know 0 multiply anything would be 0. So when we move the exponent to the front, if there is a coefficient in front, we can go ahead and multiply that one, which means lead us to the next example, which is constant multiple rule. Okay? Alright, so let's look at example 2a. We know that we can rewrite this one as 2x negative 1. So y primes, what that means is I'm going to multiply my coefficient with the exponent, which is turned into negative 2, x negative 1 minus 1. So that would be negative 2x negative 2, or we rewrite this as negative 2 over x squared. Alright, the next one, if I'm going to rewrite this, it looks like a fraction. So by rewrite this, it's make it easier for you to see which one should I multiply and which one I should not to do anything with it. So f primes, right? What I would do is that I'm take the exponent, which is 2, times 4 over 5, which just give me 8 over 5 t 2 minus 1, which would mean the equation going to be equal to 8 over 5. Sorry. Let me write over here. So equal to 8 over 5 t to the first power. So that would be the slope of f of t for t squared over 5. Same thing with example C. Y prime. Again, I'm going to rewrite this as 2 times x1 over 2 to the power of 1 over 2, right? We rewrite the radical. So most of the time, if you see the radical or the exponents on the denominator, I would move to the top. If it's a radical, I would rewrite that as fraction, so it's make it easier for me to find the derivative. So in this case, 1/2 times 2, if we multiply, if you look at this one, I'm taking the exponent, multiply the coefficient, so 1/2 times 2, which would give me 1, x, and then I would have 1/2 minus 1, which would give me 1x negative 1/2. If I rewrite this, so that would be 1 over square root of x, because 1/2 is the same as square root of x. So this is what we call the constant multiple roots. That means if I have a coefficient, I'm just go ahead and multiply that with the exponents. And the exponents, each time that you take derivative, you minus by 1. Okay, before we end this example, I need to go back. I'm going to erase this part right here because it's called a special case of power root. There will be times that you will have a function when x to the first power. So if look at this example, f of x is equal to x. Think about this. If you think about this line, it's a straight line, right? And the slope of this one should be 1. Why is that? So if we take the derivative, right, that is mean x to the first power. So move x the 1 to the front. 1 minus 1. So 1 times x to the 0, which we know anything to the 0 is 1. So 1 times 1 is just 1. So the slope of one variable that will give you, will turn that into 1. Alrighty, so this the most basic derivative function. This is the most basic derivative rules that we're going to use most of the time to find derivative. So hopefully you enjoyed this better than what we learned from last week. Alright, thanks for listening. If you found my mistake and if you see that my writing is horrible, just be patient. I will, once I get the stylish pen, hopefully that this will be better. Alright, enjoy the day.